All right, so that was all about using mantra. A lot of people ask about how to use LOPS, how to use Solaris, how to use Karma now. So I want to spend a little bit of time at the end of the lesson here to do a little bit of a bonus chapter, or chapters, bonus unit, about how to import what we did and more or less replicate everything in Karma. Unfortunately, it's not that hard. Or I should say, how to replicate it in Solaris. It's still not that hard. Before we switch over to it, I already know one thing that would trip you up right off the bat, which is, let's say I want to import my concrete into it. So looking at the concrete down here, there's this thing, this path attribute. Now I don't know how much you know about Solaris, and again, this is a bonus chapter where I'm not gonna go, I can't teach you Solaris bottom to top right now, but suffice to say, Solaris and USD, which is what Solaris is in Houdini, is all about building a scene graph tree of pieces and then how those pieces relate to each other and what lights are attached to what. In any case, when we bring stuff in from regular Houdini from SOPs into LOPS, Solaris, it's going to try to put those things into the USD tree. And what it's going to look for, by default anyway, is the path. So the path here is insane. These paths were made back with our RBD configure nodes. When these pieces were first packed, it basically made this path to it. We don't want that. We want to use the thing that actually uniquely identifies these, which is their names. So just be aware that as we move over into Solaris, that's the first gotcha. If we use the path, it's going to get confused. It's going to take a really long time to import this, and it's just ultimately not really going to work the way we want. So with that in mind, let's switch our desktop over to Solaris. And it'll look something like this. I mean, you never really need to use these desktops, but I just wanted a quick and easy way to get a scene graph tree here. I'm going to move this over here. I'm also going to click on the headlight mode because I just want a pretty regular looking viewport. And finally, go to the stage. The stage is where the magic of Solaris happens. So let's go get that concrete. To do that, we need a SOP import. Makes sense. We want to bring SOPs into here. Before we do it though, as I said, go open up primitive definition, turn on path attributes, and get rid of path. We don't want to use it. We only want to use name. So with that done, let's grab it. No, it's already there. So in your output thing, choose concrete, and we sit, and it'll take not an insignificant amount of time, but there it is. Again, that'll take like 10 times as long. There it is. If we hadn't changed that down here first. I'm not even going to demonstrate that because it's horrible. In any case, so there it is. We can see it populated all this stuff down here. And what is this? Well, by default, packed primitives, I'll even just turn it on so you can see it easier, but it'll still just be the default. By default, it will say, hey, if you find packed primitives, then consider them instances, which of course they are. We can do two things here. We can create, well, three things, I guess, really. Create X-forms means make them not be instances. Like if you did a unique fracture of a pig head or a sculpture like we talked way back at the beginning of this whole lesson, where if we can't reuse instances, like we're not getting multiple copies of one instance, then you're not gaining anything from using instances. So if every single piece is unique, you might as well choose create X-forms. Now don't do that here because we absolutely are gaining a huge advantage from some of these pieces are being used over 100 times. So don't do that. Keep that here. I guess some of the pieces aren't being used 100 times, but they're being used quite often. But that's what X-forms would get you. It would just create regular non-instance geometry. Native instances, the default, will basically use USD's kind of equivalent of packed primitives, where it is a thing, a primitive, which is stored here under prototypes. These are the unique ones. And then they're being copied around to all these other ones. So you can see if we take concrete column blah, 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 we can see they're all actually using the same underlying primitive, or the same underlying prototype. Well, I guess it's a primitive and a prototype. Point is that these all have the same name. And then they're simply being transformed into their final position, much the way like how our packed geometry had a packed full transform intrinsic that put it into its final location. That's how instances work. Even better than this, though, is point instancer. Point instancer gives us less control, but is even faster. So if I were to like scrub this in the timeline, it'll actually update pretty fast. No, it's not updating as fast as I'd hoped for this demo, but it should be it'll be faster anyway than the native instances. You can see how it loads the pieces as it goes. But there you have it. So we've pretty much done it in the general sense. We've brought the geometry in, certainly. If we needed to just apply one material to the whole thing, we could do that now. Well, let's just bring the materials in. Let's make it more concrete. So put a material library down, attach it, and you might be wondering, do we need to create our materials all over again? Well, we actually don't. Karma and Mantra are both made by side effects. They're both in Houdini, and they both use the Vex language to do their shading. In fact, we can literally reuse the same shaders. Take this material network here, point it to the shaders we already had, or materials, if you will, and if we say autofill materials, it will just go through them all, make an entry for each, and now you can see them here in our scene graph tray. There they are. There can be differences in how they will actually end up shading in the render, but they should be pretty close. There's one significant difference we'll find as we move through this, but much of it will work exactly the same. And even that one thing that doesn't work, I think, is just a bug that they can probably fix. At any rate, so there we go. We have our materials. So let's say we wanted to apply our exterior dark to the columns. So we know if we look in here, there's the columns right on top, so that'll be easy. I can look inside of it and see there's that mesh. I can either apply the material, depending on what level I apply the material, will determine how it gets shaded. So actually also I want to change the import path prefix on our SOP import to concrete. So I just want this to say concrete instead of SOP import. There you go. Keep it nice and organized. At any rate, so if I were to say put concrete for this exterior dark, so see how it says material VOP, then the material path, which is where it's going in here, and then it says assigned to geometry path. So this is the geometry path. And there it is. So now everything has that. Now obviously, that's not really what I wanted. If I take the concrete column specifically, well, it's going to shade one of those things, that color. Notice that you saw nothing change here. There's still a decent amount of bugginess in the viewport, especially in LOPS. You can try to disable this and turn it back on. That can fix it. It actually might have fixed it because we only applied it to one piece. So let's put an asterisk to wildcard so it's doing all concrete column everything. So there you go. So it applied it to just the concrete columns. And specifically, note that we did it in the prototypes. So the source instances, the things that are being copied around, we're applying the material to the source, and then everything gets it because they are, again, point instances of the source. But we kind of reached a dead end. Even if I applied it to this, where I said concrete column star / concrete column star, I mean, it's still just the concrete column. Or not even here. We might have to change our frame. That's the big guns when you need things to work. Say, I had to change the frame to make it show up. But we're not getting that kind of subdivision of, remember, the inside versus outside stuff where we had the different materials. So we need to actually go back to this and say we need some subdivisions based on that, based on those materials. So go down to import data, roll that out, and turn on partition attributes. Partition attributes will say make subsets of this stuff based on unique values of an attribute. Now that attribute is our material. Now it's not here. I see path, but that's not what we want. We don't see shop material path here because just like other packed stuff, it's on the inside of the packing. It's not exposed to the outside, but we know it's there. So type shop material path. Let that sit, and you'll notice once this comes back, we got a little plus sign here now. And now we can see that there are geom subsets inside these things. This is actually a better case. This piece has an interior material sometimes, and it has the exterior material sometimes. So these geom subsets are what we actually need to ultimately apply the stuff to. So let's just take, again, an example one. So the material concrete interior, because that's what we're talking about. Or no, we're not talking about interior. We're talking about dark. So take the dark one here, bring it up to the dark one here. Again, this whole thing is for the dark. And I'll make this come out a little bit. And you can see this is what we're targeting. Really anything, any subset that has shop material path in its name, or rather shop material path matte concrete exterior dark. Anything that has this in its name is what we want to give the concrete exterior dark. So turn this into a wildcard, or rather between the backslashes into a wildcard, and then between these backslashes into a wildcard. And now anything that has a subset called this. Now once again, we don't see it happening, and I lost a lot of sleep over why this wasn't working until I realized that it does work, and you just need to jostle the viewport into working. So I changed the frame again, and now it works. The dark is on the outside and not on the inside. Perfect. So all we have to do now is update the rest of these. So I'm going to make this full screen to make it a little bit easier, because the rest of them will be similar. So copy this to the exterior light and just change this to exterior light. Copy it to here, concrete interior. So get rid of exterior and dark and just put interior. We can come back out here, and once again, it doesn't look like it did anything. So just change the frame. I'm just using the arrow keys on my keyboard, and we can see it works. Huzzah!